Bismillahirrahmanirrahim. This is to announce a new online course entitled Realist Statistics, a Radical Approach. This video will explain why a new approach to conventional statistics is necessary. So one of the most popular textbooks in statistics is called How to Lie with Statistics. It has sold millions of copies, more than all other statistics textbooks combined. In order to understand why we need to rebuild statistics on new foundations, we have to understand why it is so easy to lie with statistics. Any approach to building a discipline of knowledge rests on certain philosophical foundations which describe what knowledge is and how you arrive at it. This can be broken down into ontology, which explains or assumes what exists in the world, and epistemology, which is what human knowledge consists of, and a methodology, which means the methods we use to acquire knowledge. All three of these were built on the basis of the philosophy of logical positivism, and this philosophy was fatally flawed and was disproven or proven to be catastrophically wrong in the later in the 20th century. However, the foundations of statistics which were built on this philosophy were never revisited, and that is why modern statistics rests on deeply flawed foundations and needs to be revised from the ground up. So to understand how this occurred, why the entire discipline was built on wrong foundations, we have to give a brief review of European intellectual history. And this goes back a long ways to the Dark Ages, where there was very little knowledge in all of Europe, until the reconquest of Al-Andalus, or Islamic Spain, which gave Europeans access to millions of books, and the translations of these books flooded Europe with new knowledge. Influx of this new knowledge was dramatically in conflict with traditional beliefs and Catholicism, and there was a battle between the new knowledge and the old, which is referred to as the battle between science and religion. And in the course of this, Christianity was split into factions, and there was bloody religious warfare, and the Europeans began to distrust religion as a source of knowledge because it led to so much bloodshed. And so they sought for new methods to build knowledge on objective secular grounds without any moral assumptions or foundations. When they rejected religion, Europeans were forced to discard their entire intellectual tradition, which was built on the basis of Christian faith. And so they were forced to start from zero, which is what accounts from Descartes, the father of modern Western philosophy, starting from the philosophy that I think, therefore I am. This is a very strange and unusual place to start, where you start at zero and try to prove your own existence. Now, this argument is actually flawed and wrong, because when you say the word I, you automatically assume existence. And in fact, the process of reason, where you start with some assumptions and then you prove something else, can never lead to new knowledge, because what is derived logically from premises is knowledge that is already contained in the premises. But the Europeans, intellectuals, were forced to start from zero and try to arrive at knowledge, because they had no collective consensus on a basis for knowledge, because of the fratricidal warfare between Christian factions. So European attempts to build knowledge on secure foundations, starting from zero with no assumptions about anything, and to create an objective and universally valid form of knowledge, received their final polished form in the philosophy of logical positivism, which was developed in the early 20th century. According to this philosophy, the ontology is that we can rely on the existence of only that which we can touch and see and feel, The epistemology or the theory of knowledge said that knowledge should only concern the observables. What is unobservable, like God, afterlife, angels, is not part of human knowledge. And the methodology then consisted of looking at patterns in what we can see, the observables, and using these to build knowledge. And all of these foundational principles are built into the modern conventional statistics, and all of these principles are fundamentally flawed and wrong, and that is why modern statistics is built on the wrong foundations. So basically, logical positivism makes it impossible to do statistics because the central concepts of statistics are unobservable, and logical positivism denies the relevance of the unobservable to not human knowledge. So what are these unobservable concepts? One of these is probability, which is correctly defined as, yes, this event happened, but something else might have happened. But what might have happened is never observable. And similarly, causality refers to when you say that one event A caused B, then you're also saying that if this event A had not happened, then event B would not have happened. And both of these are about what alternative which might have been but were not, and neither of these is observable. As a consequence of denying the relevance of what might have been, modern statistics has no satisfactory definition of either probability or causality. The currently dominant definitions, frequency theory and Bayesian or subjective probability theory, are both deeply and fundamentally flawed. And furthermore, there is no way to deduce causality from observations alone. All you can do is look at correlations, and correlations do not suffice to tell you about causation. So basically, logical positivism makes it impossible to do statistics correctly. So we've already explained that the probability refers to what might have been. Now, in order to try to avoid this problem, statisticians developed the frequency theory definition, which says that the probability of a coin coming up heads is defined by doing an infinite sequence of coin flips. Now, this is something that is impossible to do. One might think that an infinite sequence can be replaced by a very large sequence, a million flips or a billion flips or a trillion flips, but this is not true. No amount of finite number of flips can get anywhere close to infinity. And so basically the definition of the frequency theory definition of probability is fundamentally flawed. It doesn't begin to define probability. Other alternatives are also equally flawed. Similarly, modern statistics has no theory of causation at all. A deeper study shows that causation can never be part of the data. It is something that is additional, superimposed on the data by a model which describes the real-world connections between the data. And so the data is completely helpless in telling us about causality. It can only tell us correlations, and these translate to causal hypothesis only when we add some real-world mechanisms to the data and superimpose them. And so basically, since logical positivism denies the relevance or importance of the unobservable real world, it makes it impossible to discover causal mechanisms from data. To make matters worse, there is Lord Kelvin's dictum, which comes from physics, where accurate measurements were very important to the advances in physics. This idea that basically knowledge consists of only things that we can measure. If we can't measure something, then we don't have knowledge about it, has led to massively disastrous theories, especially in business, where they say that if you cannot measure something, you cannot manage it or improve it. So the positivist view of statistics is concerned solely with the numbers because that's where knowledge is, according to the Lord Kelvin. So here, if we can sketch it, the reality is the hidden submerged base. On top we have the observable, the floating part of the iceberg. But even that there are some qualitative aspects, which is that we shiver when we approach it. We have some associations with the picture. We have some impressions and some feelings. These are qualitative aspects of what we see on top. But then there are quantitative aspects, the temperature of the iceberg, the volume, the shape of it in terms of metrics, and the material compositions. And now the positivist theory of knowledge tells us that we should deal only with these numbers, and that's where knowledge is. In contrast with this, the realist view, which we will advocate in this new approach to statistics, says that knowledge is really about the hidden real world. And so we analyze numbers only to get, and we look at the observations, and we look at both qualitative and quantitative aspects to try to get clues about the hidden reality. And so you can see that these two are very different views about the nature of knowledge, and also about how we should think about organizing numbers and how using them. So in the positivist view, the numbers are all there is, and we should just analyze the numbers. The realist views the numbers as clues to the hidden reality and tries to reconstruct hidden reality on the basis of these numbers. So these approaches, these ideas about the philosophy of knowledge lead to dramatic methodological differences. In the real approach, which we will advocate, the data provide clues about the real world. Knowledge is primarily about the unobservable real world, the probabilities and the causal mechanism, and the numbers are not directly relevant. They are only relevant as clues to the hidden real world. As opposed to this, the positivist methodology says that statistics deals with analysis of data sets. It doesn't matter where they come from because the real world doesn't matter for knowledge. And numerical knowledge is the best and most accurate type of knowledge. And it's a well-known aphorism that numbers don't lie. So when you have those numbers, then you have got the truth. This is very opposed to the realist idea, which says the numbers are just not relevant for knowledge. They are just clues to what you need to know. So these are abstract ideas, and it's useful to translate them into a concrete form to understand how this works. Suppose that we want to improve the quality of research at some university. The problem is that the quality of research is unobservable, unmeasurable, unquantifiable. So what do we do? Well, if we work within the positivist paradigm, then what we would do is we would try to find measurable indicators. So we would start counting the number of journal publications and look at the impact factors and get some number to evaluate the measures of quality of research. This is actually what has been done on a large scale around the world, and it has led to a massive increase in garbage publications and garbage journals because people are just trying to improve the metrics. Now, if we were being a realist about this, we would start by discussing the purpose. What do we mean by quality research? And one obvious way to define it is to think about service to mankind. And so we want to use research which actually helps us do things. So then we would focus on applied research, and we would reject the theory practice definition that one person is only supposed to do the theory and it is the job of someone else to take this theory and apply it to the real world. We would say that develop theories which actually help solve real world problems, and we evaluate research on the basis of how much it has helped in terms of solutions of real world problems. You can see that there are dramatic differences between the real approach and the positivist approach. In addition to this philosophical problem, there is a specific problem that emerges from how Fisher decided to solve the problem of lack of computational abilities What he did was actually a brilliant solution, an imaginative solution. He said that let us imagine that the data is actually coming from a parent population. The data is not there on its own standing. It is actually representing some real world population, and this real world imaginary population is characterized by a few parameters. So once you make that assumption that the data is, for example, normal, then you only need two numbers to characterize the normal distribution. So the data can be reduced to two numbers. And basically that's what Fisher defines statistics to be about. Fisher said that statistics is about reduction of data. You take 1,000 points or 1,000,000 points of data and reduce them to two numbers or three numbers or 4 or 5 or 6, but anyway a small number of numbers. And the methodology he developed to do this was ingenious. He added an imaginary population which could be characterized by a few numbers, and he treated the data as if it came from this imaginary population. What was brilliant for his time was actually has proven to be a fatal obstruction in terms of development in statistics, because people have adopted this methodology without understanding why Fisher developed this methodology, and without understanding that it has been rendered obsolete by developments in computational capabilities. Now we do not need to reduce the data because we can deal directly with large data sets. So the use of these Fisherian type assumptions leads to the idea that the data is normal, and if you analyze the data as if it is normal, when in fact it is not normal, and that's the general case, it leads to disastrous results, disastrous inferences, and many studies have been made of how massively wrong inferences have resulted from the assumptions that the data comes from some real world imaginary population in accordance with the methodology of Fisher. It's worth noting that this methodology comes from logical positivism, because once you remove the idea that there is real knowledge, there is something real world, then you can imagine any structure. You can put any real world structure, any imagined structure for the data, and you don't need to confirm because whether this imagination is matching the real world. And this is what leads to the Fisherian methodology. So to explain this a little bit further, there is a hidden reality which we don't know anything about. Then there is observables. And now what we will advocate in our real statistics course is that we need to build models of the real world based on the observables. So using the observables, we try to guess at what is the reality which generated this data, and then our real models we will try to match with the hidden reality to see, is our real model a correct description of the invisible. This is not true for the imaginary models of Fisher. The Fisherian models are never matched to hidden reality because the positivist says that there is no need to match your model to hidden reality because hidden reality does not matter for human knowledge. So basically imaginary models are checked for a match to the observables because that's all we have. And this is a huge mistake. As I already said, there has been a massive increase in computational capabilities, and so the Fisher's idea that statistics is about reduction of the data is no longer relevant or valid, and it has become an obstacle because statisticians just work according to the template provided by Fisher about how to do statistics without realizing that the Fisherian template was created because of lack of computational abilities and is no longer necessary. And in fact, it's a huge handicap and an obstacle because imposing imaginary distributions on data hurts our ability to make correct inferences from data. So the key takeaway here is that the central project of real statistics, the course that we plan to teach, is how does data connect to hidden reality? How can we reconstruct hidden real structures from the data? In particular, the things that we are most interested is the probabilities and the causalities which emerge. And these are not part of the data at all. They are part of the real structures which are hidden behind the data. And then we can ask, well, we make some guesses about these hidden realities on the basis of the data and on the basis of other qualitative information that we have about the real world. And then how can we verify these hypotheses? How can we confirm these hypotheses? Because we don't have direct access to the hidden reality. So the only kind of test that we would have is indirect. This is in a dramatic contrast with the positivist statistics, which says that hidden reality does not matter. So they are concerned only with how to build a model for the data and how the model matches the data, not the hidden reality. Any model which has a good match to the data will do, and there is no concern with matching hidden reality. So our course is entitled Real Statistics, a Radical Approach. As we have discussed, ontology, epistemology, and methodology of modern statistics have been built on dramatically flawed foundations of logical positivist philosophy, and real statistics will be built on replacing all three. We have a different ontology. We believe in the existence of hidden real world objects like causality and probability, and we believe that knowledge is about these hidden real world structures. And then we have to construct a methodology which will allow us to access these real world structures using the data that we have. To register for this upcoming course, use the register on the Google document, and those who register will get access to course materials and get links to where the course will be, lectures will be held, and further instructions.